Welcome to Geoscience Engineering. In the previous video, we have discussed about the permittivity a little. Now we'll go into in depth. So here we are discussing about why water changes the GPR results. Imagine you are shouting in an empty room. Your voice travels clearly and it comes back and you can listen it clearly. Imagine if you are doing the same thing underwater. That will be completely different, right? That is because the sound waves or the waves, they are passing very slow inside the water. The same thing happens with the GPR also. And the biggest reason is presence of water or moisture inside the subsurface. Now, even a small quantity of moisture can completely change the results of a GPR. So if you can see it here clearly, I'll show you. Now, why does water affect GPR so much? In the previous video, we have discussed about the permittivity of air, which gives more or clean data. And when it comes to the mud or surface with more moisture, it will give you an irregular data. Now, let us understand this in a simpler way. Permittivity will tell you how much the material is interacting with the electromagnetic waves. So higher the permittivity means the waves will slow down. If you take mud or if you take water or clay, permittivity will be very high and the waves will slow down. And water is having an approximate permittivity of 80, but in the air it is 1, and in the dry soil it will be around 3 to 10. So when we are going for a GPR survey, we have to consider maximum dry surface. So water has the higher influence on the wave. That means when the surface gets wet, maybe because of the rain, the GPR signal will loses its energy fast. That means the depth of penetration here, if you see, it will be less. So that is why sometimes GPR works when you are working on the dry sand or dry places, and it performs very poor when you have a waterlogged or wet clay in it. Now we'll take two examples. Here if you see in the first example, it's area 1 is dry soil and area 2 is wet soil. Now in the area 1, the velocity dry soil, the velocity is 0.15 meter per nanosecond and the time is 100 nanoseconds. So when you calculated the depth using v equal to depth equal to velocity into time by 2, then you will have this approximate value, this value of 7.5 meters. That is because it's a dry place, and here in the wet soil the velocity is 0.08 meters per nanosecond, and when you do the measurement it will be like 4 meters. It's shallow because the velocity is low. Now uh, when we are comparing both of them, the travel time is same, but they are showing completely different depth. Sometimes the signal is getting absorbed because the soil contains water or clay, and this is one of the biggest mistake in the beginning of interpretation. So when you are going for a GPR survey, you have to find out what is the moisture content in the ground, or if someone did the survey and you need to ask them, uh, is that place completely of moisture or is it dry? This is how you will do the interpretation part. In the upcoming videos, we will also see why clay destroys the GPR penetration, and like here the frequency selection is also dependent. So we'll discuss about why frequency selection also matters and how the professionals will estimate subsurface conditions before a survey. So this will make you understand clearly how to use the GPR in any kind of terrain. So we'll continue this series, and please do subscribe and watch the total series so you'll understand how the GPR works and how to do a survey and how to interpret the data also. Thank you.